Hi everyone, this is video 4 for section 2.2 and 2.3, whole numbers and numeral systems. So we're continuing our discussion of the base B numeral system, right, that we left off last time with examples of base 5 and base 16. So today we're going to continue to talk about how to interpret numbers in this base B system. So whenever we have a number that's written in base B, we have what's called the expanded form of that number, which is the sum of the product of each digit times its place value, where again, the place value is the ones place, the b place, the b squared, b cubed, and so on, just like how in our standard base 10, we have the ones, tens, hundreds, thousands, and so on. So we want to write each of these in an expanded form. So let's start with A. So A, right, this is just 253, and you see that there's nothing written right here for the base. So when we see something written in a base B system, the base will normally be written like so, right? So we have this subscript after the number that tells us the base that it's in. So if there's nothing written there, that just means that it's in base 10 because that is our standard. So this 253 is just 253 base 10. It's the 253 that we look at, and its value, its amount that it represents is actually 253. So let's see why. So this is base 10 because it doesn't have a base down there to tell us differently. So remember that we have these place values. So we have the 10 cubed. Well, let me write them backwards like we've been doing, right? We have the ones place, the tens place, the 10 squareds place, which is the hundredth place, and the 10 cubed. So you notice that whenever I've written these, I've only ever gone to the cubed. That's a fair assumption to make, that in this class you won't have to deal with anything higher than the base B cubed power. But now let's fill in where these numbers go, right? So when we have this positional numeral system, so where each number is, so where each numeral is, tells us where it goes in these places. So the number on the furthest right goes in the ones, and then we can just fill it in backwards, like so. So we have 2 in the hundreds place, 5 in the tens place, and 3 in the ones place. So whenever we're writing out the expanded form, we have that 253 is 2 times the value in that place, which is 10 squared, which is 100, plus we have 5 times in the tens place. We can go ahead and put a 1 here. And then 3 times the ones place. So we can write it like this. So I prefer to write it out fully with the parentheses just because although multiplication does come first in the order of operations, I just want it to be really, really clear that you multiply these numbers together first. And you can write it either way that you prefer. This just helps me make sure that I know what's going on and just kind of group it as the first set of parentheses is the 10 squared place, then the tens place, then the ones place, each parenthesis denoting the value that comes from that place. Okay, so that was the standard base 10 example. So all of that should seem pretty natural to you. So now let's go to an example with base 16. Remember we talked about base 16 at the very end of last video. So with base 16, right, so we're gonna have, so it's not 10, see, I'm just so used to base 10, so we're gonna have the 16 cubed place, 16 squared place, 16's place, and the ones place. So right there. So again, we can fill it in backwards. So we're gonna have E in the ones place, and remember E represents 14 because F represents 15. So then we're gonna have 4 in the 16's place, 0 in the 16 squareds place, and 1 and the 16 cubes place. So these are the places that each of these denote. And so now let's write out the expanded form. So 104e base 16. So this base 16, I know that in this is typed out with the word 16 as this subscript, but it's often denoted with base 16 with that numeral denoting 16 rather than the word denoting 16. So just be aware that it can be written in either way so that you understand what it's saying. So 104e base 16, we can write it out. So this one has something in the 16 cubes place, so we're going to start with that. So 1 times 16 cubed plus 0 times 16 squared plus 4 times 16 plus e times 1. So at this point, you may not really want to have e written out like this, because everything now in this equation is one of our European numerals. So in this case, you can write 14 instead of e because e represents the value 14. So it's up to you which one you want to write, but just you should be able to, when you're dealing with base 16, this hexadecimal system, you should be able to see any of the letters and know what value is associated to that letter. So this is how this one's written out. So this next one is in base 2. So base 2 is a little bit special. It has a special name. It's called binary. So this is, again, talked about on page 60 of chapter 2. So this binary numeral system is really, really important for computer science. So you'll see that it's only zeros and ones, because remember, in a base that's lower than 10, our different digits are 0 up to 1 minus that number, which is, in this case, just 0 and 1, because we can't include 2. So yeah, this is really important in computer science. If any of you have any interest in programming or teaching programming, I know programming is being taught at a lot more schools these days. But yeah, binary is really important for that because computers are coded in binary where there's zeros and ones, and those zeros and ones represent kind of an on-off switch. So an on-off switch to help circuits in computers run. So that's a really interesting thing about base 2 is that all of our computer systems are literally built on base 2 numbers. Okay, but now let's write out the expanded form of this problem. So again, this is in base 2. So we have the 2 cubed place, the 2 squareds place, the 2's place, and the 1's place. So again, we just fill in all of our numbers, 1, 0, 1, 1. And now we can write out the expanded form. So again, this has a written out in words 2, but we can also represent it by a numeral 2 for our base. So this is 1 times 2 cubed plus 0 times 2 squared plus 1 times 2 plus 1 times 1. And this is how you can write that out. Okay, our last example is base 5. So it's 432 base 5. So base 5 was another one of the ones we talked about last video. Okay, so this, right, is in base 5. And like normal, we have the 5 cubed place, the 5 squared place, the 5's place, and the 1's place. The 5 cubes place, because it only has 3 digits, it's only going to have 3 places. So this is 432, 432. So now let's write out that expanded form. So we have 432 base 5 is going to be 4 times 5 squared plus 3 times 5 plus 2 times 1. Okay, So we can write out these expanded forms, and this is really helpful if we're trying to convert things between different bases, because now we know exactly what this number actually represents, right? We know the value. So once we convert this to this expanded form, it's a lot easier to calculate the value of what these numerals, what number they actually represent. And so once we know that, it's a pretty simple process to convert it to base 10. So converting things to base 10 is pretty simple because we have this expanded form and we just compute it. So let's go to the first example. So we have 104, 104e base 16. Okay, so these are just going to mirror the examples that we did right above. So we have 104e base 16. So I'm just going to copy the expanded form that we wrote right above. So we have 1 times 16 cubed plus 0 times 16 squared plus 4 times 16 plus e times 1, right? So this is the expanded form that we have for this example right above. So whenever we want to convert these things to base 10, we just multiply them out and simplify this expression. So the first thing is 16 cubed. So you may not know 16 cubed off the top of your head, and that's fine. We can just multiply out on the side to get it. So 16 squared is 256. Again, you may not know that off the top of your head, but if you don't, go ahead and write out all your work. And now 16 cubed is going to be 256 times 16. So 6 times 6 is 36. We carry the 3. 6 times 5 is 30. Add the 3, carry the 3. 2 times 6 is 12, so this is 15. 36. And then we have 256. So when we add this all together, we get 4,096 is 16 cubed. So this is 4,096 plus 0 times 16 squared is just 0. 4 times 16, again, you may not know this off the top of your head, but it is 64. And then plus e times 1. So this is the case where you need to convert e to what it actually represents, what amount it actually represents, and that is 14. And then we just add all of these things together. So again, if you can't do this in your head, that's fine. Just make sure you write out all of your scratch work to the side. So we're adding 4,096, 64, and 14. So in our ones place, we get 14. We carry the 1. In our tens place, we get 17 and carry the 1. And then we get 1, and then we get 4. So this is 4,174. Okay, so this is our converted number in base 10. Okay, now I'm going to do the next one. So again, we just rewrite our expanded form that we had above. So this is 1011 base 2, which was 1 times 2 cubed plus 0 times 2 squared plus 1 times 2 plus 1 times 1. So we just keep writing this out. So we expanded out this one, right? Binary is a lot easier because it's just powers of 2. So 2 times 2 times 2 is 8. And then we add 0. And then 1 times 2 is 2. And then 1 times 1 is 1. So this gives us 11. So in binary, the number 1011 gives us just an amount of 11. And lastly, we have 432 base 5. So we're going to, again, copy the expanded form that we wrote above. So this is 4 times 5 squared plus 3 times 5 plus 2 times 1. And we're going to expand this all out. So we have 4 times 25 plus 15 plus 2, which is 100, plus 15 plus 2, which is 117. So that's all we do. We just keep it, we write out the expanded form of the number, and then we add it all up in base 10. So you could add, subtract, multiply, divide. You can do every mathematical operation in a different base. That's all fine. But it's a little bit complicated, so we'll go slow when we go through these. But converting things to base 10 is pretty simple. You just write the expanded form and then do all of the operations in base 10. And that's, like I've said many times, the standard way that we write things is in base 10, that European numeral system. And that's all for this page. And so that is all for this video.